What's up, what's up? Welcome back. Today we're doing a bit of a code cleanup day, working on our Git GUI, kind of. So we have like this Git GUI. He shows a commit log, and when you click on a commit, he shows like diffs and stuff. So as part of that, we've implemented like a diff algorithm. We've been debugging our diff algorithm and improving it over the past maybe week or so. And we've kind of left ourselves in a bit of a shitty state. So here's like, the last like reasonable point, and then here in our commit history, we just have like smiley face, smiley face, smiley face, smiley face. And there's like a lot of changes baked into this. We've looked at like this like linear diff algorithm. We've added like a diff visualizer, which means that we've had to split up our algorithm into like this like state machine thing that can like extract debug info from it. So we've got like a little bit of like work to clean up in here. And so goal for today is to get some form of like committable thing. We've kind of just been like moving quick as we've been working on it, and without like really much thought for maintainability or like understandability, whatever the fuck you want to call it. So figured I'd spend a day trying to clean it up, and usually I do this stuff off stream, but I didn't. And so here we are, and I'm not really sure if this is like valuable to show at all. So we'll see how it feels, and maybe we'll do this again, maybe we won't. Who knows? So plan of action is approximately we need to figure out what we've even done. Once we have that, we can kind of like think about, well, what are the like chunks of work that are in here? What are like the commits that we can like create to this? And then we can like start splitting out commits. And once we have like small reviewable chunks of work, then we can start looking at like, okay, how do we make these like better and like actually usable? Maybe they're already like almost there, maybe not. I don't really know. So that's where we're at. So I think we got to figure out what we're working with. So let's just kind of see where we are relative to our current master branch, and kind of like just start trying to figure out what is even in here. What's in here? So we have some stuff related to like addition of the diff visualizer. We have, this is all diff visualizer stuff. So I think I'm pretty confident that all of this is going to be new code. We can like look at it a little more closely later, but I think that probably that'll all come in as one chunk. Probably. We have some stuff here about our diff builder. He now can like take in a large chunk of work at once, or like how do I explain this? Okay, diff algorithm. We have this like 2D grid, essentially. Boom, 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 boom. I should just use the fucking programming route. Hold on. We can go back to like here is probably the best place to show it from. If we cargo build, we'll give it a sec. Give him a second. He's got to think. Okay. And then somewhere we'll have a command that kind of works. Okay, here we go. So the diff algorithm kind of works by, we build up like a 2D grid that represents this like diff in some way, with where the x-axis is the string that we're trying to like come from, and the y-axis is the string that we're trying to get to. And then there's like some things that it's doing to try to like split up the work into smaller chunks. And then he does this like kind of like breadth first search where he tries to find a path from one corner to the other. We're not going to go too into detail, I don't think. Maybe we will later. But the idea is this like diff builder, what he's doing is he walks this path backwards. He goes from like the bottom right to the top left, and he says like, I'm going to like collect all of the like actions that we took to get here. And that's how we like build up our diff from file A to B. Anyways. So what was I doing? I was looking at git diff tool, and we were looking at somewhere in here. We were looking at, okay, so as we're doing that like backwards walk, we basically said we added support for longer diagonals. So before, when we walked backwards, we'd like look at this node, then we look at this node, then we look at this node, and we would say like, We're going one step at a time, and as we went one step at a time, we would like increment this like traversal, we called it. And it looks like this change is basically saying we can do that in one shot. So diff builder one shot length. Not really sure why we did that right now. I can't really remember, but we'll see. Looks like there's some changes here where we deleted Myers trace, but we moved the stuff in it to line 264. So what's at line 264? 264. So that turned into like the forgetful Myers trace. I see. So there's like a tracing split into full and forgetful. So the idea here is before we did all of this work, we only had this like forwards pass version of the algorithm. So it was like, how do I maybe, here we go. So the original version of the algorithm basically took one big box and he did this like large walk. The reason that we made all these changes to begin with is that this becomes very expensive as your path gets larger and larger, because in order to remember how to get back from the bottom right to the top left, you need to remember the path that you took for each branch of the search that you're doing. So the technique to avoid that is to do this like forgetful version of the walk in both directions, and then you can like slam them into each other. So hold on, let's see. Let's limit memory a little bit more. And the idea is that like as they walk backwards, as on this like initial walk, they don't know how to get back to where they came from, but they just know that they're still taking like the most optimal path. And the idea is that at some point they slam into each other and then we bisect the problem. So one of the things that we did was we bisected the storage of this algorithm so that there's like the stupid forgetful version of the storage and like the good memory, like the full memory version. So that's another thing that's in there. What else? We did some like, this is like deduplication of some of the like algorithm internals. Which I think probably is going to be relevant even before we make any of our changes. So that's going to be probably one of the first commits we pull out. This is just some split out of some existing code to calculate how much memory a like full walk will take, and it looks like that basically code already existed, but we pulled it into a function. So I don't think I'm gonna like make a bullet for that. I think that's fine. This is like the forgetful and full version of the trace stuff. Yep. Okay. This is more of that where we have to support using both versions. Sure. Then there's this like debug info stuff, right? So we kind of like split for loops into state machines with internal debug info. Then we implemented the linear version. Wow, there's like actually a lot of shit in here. Holy. This is all linear version implementation. This is the original version split out into a state machine. What is this? Extract from source. I don't know what this does. Extract from source. What is that? Extract from source. So this guy is used to say, hey, I have some content inside a list. Okay, yeah. This is support for forwards and backwards walking of the algorithm. Right. Implemented forwards and backwards iteration. Okay, so probably what we're gonna end up with is, let's see, diff builder one shot length. So this is a simple thing that we can do at the start. Maybe not. Maybe this will make sense to do once we actually have to use it. There's probably a reason that we did that. Diff visualizer probably comes in towards the end. Algorithm internal deduplication probably is one of like the first things that we look at. Then probably we throw the like we do like an initial state machine split from like the original for loop algorithm. We pull out the like state machine, and at that point we can implement like a really shitty version of the diff visualizer. Yeah, that looks like a good sequence, probably. And then we add the full and forgetful versions. We add forwards and backwards iteration. Then we implement linear. Yeah, I think that's pretty reasonable. Pretty reasonable. Okay. So let's start with maybe splitting out internal dedupe commit. Okay. Okay. I guess before we do any of that, though, we should probably do like a little bit of a make sure that we're like in a clean state at the end. Because what's going to happen is I'm going to like be comparing with like current state as I split out individual commits. And if the current state sucks, like heavy sucks, then it'll be hard to compare. So maybe we just do like a quick cargo format now, which changed some stuff. We'll call this format, and let's just kind of see what our stuff is complaining about. So cargo check is complaining only a little bit. There's an unused function as well as an unused variable, so we can just fix those. That's fine. So this is unused. Nice. Easy. And I think the other one was at main 432. This guy's just complaining that we don't write anything down, which is fine. And if we cargo clippy, is there anything that's like really bad? Nothing that bad, so that's a fine place to start from, I think. Oh, fuck. We're not at the right spot, though. Because we did a bunch of like OpenGL stuff at the last stream where we kind of like took our visualization, we like rewrote it in OpenGL, and it looked a lot uglier, but it supported a lot more nodes in the graph, which was useful. I think probably I'll like leave this stuff off on the side for now. That'll be like an easier thing to deal with later. So I'm not 100% sure if I want that stuff like in the final, like if I'm gonna preserve that work. I'm not sure. So let's check out rebase reference, I guess we'll call it. And we'll just say smiley face. I think. Okay. What's in here? Okay. And then let's just double check that we're not missing anything important from here to the like OpenGL stuff. So in the OpenGL stuff, we did change our like diff visualizer from taking in lists of numbers to files to diff, which I think is a reasonable change that we're probably going to want. This is formatting stuff. Fuck, we should go into this side and format this as well, or else it's going to be like a pain in the ass to compare. Okay, rebase ref. Okay. Now we can diff this with the viz branch again, and let's look a little closer. Let's look again. So yeah, there's stuff about changing from number lists to files that we're diffing. I think that's probably something that we're actually going to want. So let's add that to the list somewhere. Diff addition of the diff visualizer. Let's do file diffs. Maybe not. I'm not really sure. Because I think that the labeling on that version wasn't really complete, which makes it a little bit trickier. This is OpenGL stuff. OpenGL stuff. OpenGL stuff. OpenGL stuff. OpenGL stuff. Yeah, okay. What are on the side? That function is back. Some print lines that we moved. Sure. Okay. So we're not missing anything crazy. Not missing anything crazy. And so let's look at pulling out that initial dedupe commit. This fucking notepad is getting actually large enough that it's probably worth closing the maze. Or we can reduce font size? Yeah, there we go. There we go. Okay. Okay. So let's check out a new branch. Git checkout rebase. And let's put it back here. So git reset hard master. Okay, and then we want to see the reference rebase. Okay. And I guess we just start moving. So git checkout rebase ref. We pull in all of the changes from rebase ref. Undo everything. And start trying to pull in some of the changes. So git add -p this stuff. And actually, I guess maybe doing like an add -p. I don't know how much this is going to end up being relevant because of how much the changes have, like how much has changed. So let's actually, we'll do a different strategy at first. We'll do a different strategy first. So check it. Let's go back to our initial state, and let's just maybe we'll go into lib diff lib. This is already open. How do I show jobs? Yeah, fg neovim. Okay. And what was I trying to do? We want to pull out that like deduplication stuff. So maybe we can git show rebase ref lib diff source lib. And we can look, we say set file type equals Rust, please. I want to have some syntax highlighting. And there was this like move source direction. Here we go. Get move source. So this is the function that we wanted to pull out. And its usage is going to look very different in this version of the code, but that's okay. So this guy came kind of after diff builder-ish, so we kind of just paste this code over here. After memory limit stuff as well. So we can just slap it in here. Okay. He's saying, hey, I'm going to take a Myers trace generic type. This doesn't exist yet, so we can just say that it's going to take in a Myers trace. Yep. And now we go into our diff stuff, and basically it's what we've copied out is essentially this stuff. So where he's kind of saying, hey, there's a bunch of like data that I've written down that's related to like my tree storage format, and I want to like extract some pieces of information from there. And one of them is this if block, and one of them is this if block, and they look very, very similar. So we just have to make sure that we're reusing the same code there. And I think that we've actually, what did we do in our version on the right? Surely this like get move source is used somewhere. So when walking backwards, we just get the move source and resolve X for D and K. Okay. Yep, that makes sense. So here it's going to look something like let move source is equal to get move source, and it's going to use the trace D and K. Yo, what's up? And then he extracts the previous K. He used that to generate a previous X. So I think that stuff is here. He says, hey, this is my current X. My previous X was resolve X for DK. So that's the same code as this block here. Okay. So I guess we can pull this stuff out as well. I think that's reasonable. And calc X without diagonal. Yeah, I think these are both related as well. Damn, why do Rust projects have so much code in a single file? Well, I mean, maybe it's because I'm shit, you know? I wouldn't use my Rust code as the end-all and be-all. Because, yeah, I would say that it is quite easy to split stuff out in Rust code. We just haven't really done it. Okay, so in this version, Jesus, that's a lot of code. You're right, this is awful. Get move source. So here he says my previous K is probably, I think it's in this move source. Yeah, we have the previous K kind of embedded in here. And then he says my previous X is going to be resolve x for d and k, and then we pass in the trace as well as the move source d and move source k. Okay. And then prev y is prev x minus move source k now. Okay, so that's, I think that chunk of code dealt with. And then the other side was like the forwards pass. So that was just calc x without diagonal thing, probably. Yeah. So here it's let mut x equal to calc x without diagonal, given our trace and our d and k values. Then all of this goes away. Okay. So that at least is one chunk of work, I think. Cargo format, cargo check. Do we compile? Cargo test. All of our tests at this point in time should pass, hopefully, unless we fuck something up. Those are all still good, which means that we did the like translation of that feature correctly. And then let's maybe quickly look at it and make sure that we're like happy with the code that's actually in here. So that's this stuff up here. So how do we get to a given dk position? Assumes that the trace has been populated for 0 to d. Okay, sure. And so we take in our trace and our current d and k position. And we say, hey, where did we come from? And we say, hey, here is like the direction. It could have come from the root of the tree, it could have come from left, and could have come from up, and here are the like values associated with it, which I think is fair. That seems fair. This guy says, extract the x value associated with the given dk from the trace. This handles the edge case where the edge of the trace root and the previous dk value is valid. Also, I think reasonable. Calculate x position for a given d and k without advancing through the next diagonal. Assumes that the previous dk positions have already been walked. And so here we get the move source, we resolve x. Yeah, nothing in there seems crazy. Nothing in there seems crazy. So let's just add this and we'll say, why did we do this? Deduplicate. What is the purpose of what we just pulled out? Deduplicate backwards walking. I don't know what to call it, so maybe we'll come back to this and we'll say, we'll figure out, we'll write the long version first, and then we can write the title after. So, in multiple parts of the Myers diff extract we need to extract where extract how we got to a given node. Yeah, that makes sense. Once, as we are populating the trace data, and once as we are walking the trace backwards to build the diff. It is important that these two pieces of code are the same, otherwise we will not get the right answer when we rebuild our diff. Split out a get move source function that encapsulates this logic. This will be important as we make more changes in this area. No, we'll just delete that. We don't need to say that. Good afternoon, missed the intro. We've been following the past few streams briefly. What are we working on today? We are working on taking the things from the last few streams and trying to get them actually into the code base. So there's a lot of like kind of grossness that we've left behind, and we're trying to like split out chunks of the code into like individual small bite-sized commits, and then as we are doing that, hopefully reviewing and making sure that the changes are actually not shit. So we'll say deduplicate move deduplicate move source calculation in diff algo. Gotcha. Merging branches. Kind of more closer to like if I were at work and I were to like file a pull request, this is like the work I would do before filing the PR, so that like somebody else could understand what the fuck I did. Okay. So that's one. What is the next chunk of work that we want to look at? Split loops for into state machines. Yeah. Like, nice. I like that. State machine extraction. Okay. So one of the things that we did was we took this like big diff function, which we basically copy pasted from the this blog post. Let's see if we can find it. Myers diff algorithm. Probably part 3. Probably. Yeah, so this guy, James Coughlin, has like this like pretty cool blog on like Myers diff algorithm, and like really like helps extract like or helps understand what it is. Where is his like code? But at some point, our like the initial implementation was almost a copy paste of this algorithm here. Very similar. But we have now split this out into like a state machine, because our state machine allows us to look at like each step individually, extract some debug info, visualize it, etc., etc. So we, and also as we've like started making these changes, we understand the algorithm a lot better. So before we kind of just had this like blind copy paste, we kind of imagined it as a black box, kind of. Now we understand it better. So we can look at what we did when we like pulled out our little state machine. So that's going to be in rebase ref lib diff source lib rs again. And again, we have to say set file type equals rust. And let's just see, probably, I think that this actually changed more than it had to get here, because we tacked a bunch of changes on top, but we can probably start from what we have at the current tip and then work kind of backwards. So this guy, I want to make sure that I put him in the right spot. So this guy's basically right before this diff function. And some things that we need to like kind of reverse to make sense at this point in time. So at this point in time, the like algorithm limits don't exist. At this point, the direction walking doesn't exist. And at this point, the only version of the trace we have is a Myers trace. Max distance, do we use this anywhere? I'm not really sure about that. We'll leave that in for now. At this point in time, our construction of this guy is only going to take in A and B. His trace is going to be a Myers trace new. And here is going to use A len and B len probably directly for his like sizing. Yep. And he's not going to have forgetful version of the algorithm. He's not going to have the backwards version. But he is going to do all this stuff still. Okay. Max distance is, I guess, A len plus B len or something. Not really sure about that. We'll come back to this. I'm not really positive that this is quite correct, but we will see. And then here he doesn't have the like bounds or direction, but the rest of this stays in. I think it's actually +2 here. I guess we can see, did we have this like max distance concept in our original? We did. We had max distance was A len plus B len. Okay, cool. Cool. So this stuff goes away. And now we have to start making sure that like what we did is at least close. we want to make sure that like the diff between what we created here and what was in our original for loops is like kind of small. Okay. So this is kind of supposed to be this part of the algorithm here. So our bounds check is supposed to be... Okay, what's going on here? What's going on here? For each step of the algorithm, we loop through something. This loop is, I guess, equivalent to this while loop here, probably. And so this break condition is probably the same as this condition here. So let's just double check this. No, this while loop is this while loop here. Okay, so we'll make sure we use the same condition. Like this. And then I don't know what the fuck is going on here. Translation of outer loop. If we hit the limit of k, d has to be incremented by 1 and k has to be reset. So that makes sense. This looks like... Oh, fuck me. This looks like it's supposed to be this stuff. And so I don't understand what's going on here. Maybe this is... Oh, this is keeping us within the region of interest, which we didn't do before. So maybe this stuff goes away. Yeah, that sounds right. So maybe this kind of just looks like this for now, and we'll pull that stuff back in later. And this looks like a more direct translation of what's in the stuff on the right here. Yeah, that looks right. So here we increment our d and k, so that's this stuff here. We calculate x and y, which is this. We do this assertion, we do this while. We do this assignment, that's this guy. And then we do this like break outer here. This is the same, this is like the equivalent of an outer break, is returning that we're finished. Yeah. Cool. Cool. Okay, I think that makes sense. So here, this stuff doesn't matter yet either. And so now this is going to look like none, probably. Yeah, there we go. We don't have this diff algo action taken thing. So that would be in... do I have the diff open? Here we do, yeah. But he's stuck as stopped. So can we say background %1? Okay. And so now this should be scrollable. Nice. Okay, so here, somewhere we have that like action taken thing. We need to pull that in. Action taken. Search is fucking broken. It's very cool. Very cool. Or maybe it needs action. What is happening here? Why does this look like shit? Something's wrong. I haven't seen this happen before. That looks like a bug. Looks like a bug. But that's fine. Oh, we were probably looking at the wrong diff as well. Okay, there. We'll look at this diff. This is what we want. So we're looking for diff algo action taken. Here. So this guy lived kinda just above diff algo stuff. Okay. So we can kind of slap this guy here. I don't know if this guy needs to be debugged right now, and these are the two actions you can take at this point in time. It says max distance is never read, but I think that will come back into play. Actually, maybe it won't. What is max distance supposed to limit in like the original version? max distance was like the iteration endpoint. I see. So in this version, we had to kind of break out if we hit the max distance. But maybe we decided that that's like not important, like not required. When we got here, it seems possible. Okay, cool. Okay, so now we need to like use this like diff algo instead of doing this loop. So this is something like I'm sure this exists in here already. Yeah, here we oh, okay, he did use the max distance thing here. Okay, so let's undo that removal of max distance. And here we construct our diff algo like this. Okay. Here we have to remove some of these extra arguments that don't exist yet. And we deleted this big loop and replaced it with while algo step is not equal finished. Here we go. So this stuff can all go away. And then we need to pull let trace is equal to algo trace or something. And then does all the code below kind of work? For D, and this goes to algo.d here instead, I think. Then there's a bunch of stuff in here that like isn't really relevant. Okay, so that's a chunk of work that pulls out this state machine, and we can say cargo test to make sure that everything still is happy. If the test passed, then this like split is like doing what it used to do. Great. And maybe cargo format, cargo clippy, etc. Okay, everyone's happy there. And let's just kind of see what this diff actually looks like. Let's see if I can review this and like understand it. So let's see. This diff sucks. So if I were a reviewer, what would I look at here? I would say, okay, so they added this like algo action taken, added diff algo, and this is really hard to parse. So I would probably look at the old and new versions side by side. Probably. So this is considered to be like a moved block. This is considered new. Yeah, so I guess we need to look at... This is fucked. This is fucked. So let's just look at them side by side and see if we like what we see. So we can say git show head lib diff source lib and set file type as Rust, function diff. And see if we like what we see. So here, max distance. Does this have an equivalent? Does max distance and trace? So before we made a trace with ALN, BLN, and max memory, ALN, BLN, max memory. Max distance was ALN plus BLN. This is still ALN plus BLN. Great. They cast out I64. We cast out I64. Everyone's happy. Then we do like our loop. And we were... Before we basically, for each iteration of the loop, we increment k by 2 from negative d to d. So k starts at negative d. If k is greater than d, okay, we increment k by 2, so that's this. Each level algorithm only works on even odd k. Okay, that's fine. If k is greater than d, we increment d by 1, and we put k to negative d, so that's the same as going through this loop again, and then for each step we say calc x with the diagonal, y minus k, y equals x minus k, we assert, we while, this is the same while thing, while a is less than a, x less than a ln is I64, y is less than b ln is I64, and we are looking at a equals b for x and y plus equals 1. We set this to x, and if we are greater than or equal to the lengths, we break. And here, and so we say we're finished, and we're chilling. Okay, yeah, happy with that. Seems fine. Totally fine, totally fine. So we can say here, split diff algorithm into state machine. And so we need to justify this change. And we can say, in order to implement a diff visualizer, we need to be able to inspect the state of our diffing algorithm as it progresses. The existing API is insufficient as we can only see the diff that it produces. Extract the tree walking loop into a state machine that we can inspect at each step. Instead of a double for loop, we have a single step function that iterates, that does one iteration of the loop. Okay, that's fine. That's good enough. That's good enough. Good enough. And the next thing that we want to probably do is, the next thing that makes sense here is to kind of split out a naive version of diff visualizer, I think. That's probably what makes sense next, because otherwise, like, we want to be able to, like, visually see the improvements as we go, probably. I think that makes sense. Actually, we also have, like, backwards iteration was another thing that we split out, and so maybe we split that now as well. Yeah, let's do that. Backwards iterator split. Split. So that's, once we walk the tree forwards, we also then walk the tree backwards in order to rebuild the diff. And so I think in the latest version of the code, libdiff source lib, that's like in its own iterator, I think. Backwards iterator. Yep, here we go. Here it is. So where is this guy defined here? Yep, perfect. So here we can say that we can like copy paste this. Yoink. Stick it here. And there's some like genericism here that we don't need at this point in our lives. So this is a Myers trace just directly. So now no more T's, just Myers traces. Okay. No more T's. And the Myers trace actually isn't generic at all. Right. Okay, associated function new is never used, that's okay. And now we want to look at usage of this guy. So in this version of the code, he builds his backwards iterator, and as he walks backwards, he pushes into our like diff builder based off of what the move was. And I think I don't like this code, to be honest. Yeah, I don't like this at all. That's ugly. I think probably what makes more sense here is instead of like externally trying to cache our previous X and Y positions, maybe each iteration of this like iterator should tell us where we moved from and to. Does that make sense? So maybe we'll go to the latest and greatest and try implementing that and see what it looks like. We'll maybe ditch everything for now and check out -f, rebase ref. And let's see if we can make this a little prettier. So Myers, backwards iterator. So who uses this guy? He exports, I see. So he exports his like XY positions as like debug info for our graph drawing stuff, which makes sense. But when he's used in these diffing algorithms, we're trying to see like the change in those two. So I wonder if having both makes sense. He emits XY positions. Is there like some sort of like iterator trait that we can use in Rust to give us like windows? I know that there's like in the Rust API, there's a way to get like on a slice, you can get adjacent pieces, but I don't know if there's like an iterator way of doing that. Map windows looks promising. Nightly experimental API calls a function f for each contiguous window slice, blah 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 blah. Is there anything that's like you could use a peekable iterator, I guess, in order to like peek the next thing. So maybe that looks a little less shit than whatever the fuck we did here, right? You could say this is like a peekable version of this guy. And then you could do something like, you could say like let next x is equal it peek. Let next x next y is equal to it peek. And then you could say like if this has to succeed, otherwise you like break. And then here you say if next y is equal to y, next x is equal to x. And then everywhere here you need to put next instead. I don't really like this either, to be honest. Like none of this doesn't feel that great. Let's see. Let's see. I don't like this. But I do like it better than what we had before, probably. I guess this has to be like, I can't borrow iterator as mutable while I'm iterating it, so that's not great either. That's not great either. Like, it seems like next chunk, advance the iterator and returns an array containing the next n values. It just feels like this should exist already. It really feels like it should. Fuse creates an iterator which ends after the first none. After an iterator returns none, future calls may or may not yield some to you again. Fuse adapts an iterator, ensuring that after none is given, it always returns none. That's not what I'm looking for either. Probably in iter tools. Yeah, that seems possible. And I guess if it's in iter tools, we know it's not in the standard library. I guess this is like an extension. Map result, no. Interleave, alternate elements from two iterators until both run out. No. Intersperse, no. Zip longest. Batching? This is close, so he goes from 0 to 4 and he gives it in 0, 1, 2, 3. Chunks, also close. Tuple windows, yeah. Returns an iterator over all contiguous windows. This is... Okay. So I guess this just doesn't exist in the standard library right now. And the question is how do I want to manage that myself? It seems super useful. Seems super useful. So you could do something like, you could say like iter tools, or else we could just like make it, right? How hard can this be? How hard can it be? You would do something, let's just like, say we were to do this. Let's just feel it out. How awful is it? So we could do something like struct, like window iterator, takes in some iterator, and he's going to store his like last version. So here he's going to have some type that he's storing, and the item that the iterator is iterating should be t's. The last thing he's going to store is going to be an option t, so t almost certainly has to be sized. I guess. Maybe that doesn't have to be bound here, though. We'll see. Let's mod iter tools, we'll call it. Okay, so what's he complaining about? Parameter IT is never used, and so now we have to store the IT as well. And then we can impl iterator for window iterator. And this is going to take in, we still need the same type constraints here. So t and it which is an iterator of item equals t, okay. So now we can say t_it like this. And we implement next, which should be easy. So item is going to be tt. And this guy is just going to say, if last is none, we have to create it. So we'll say self last is equal to it self it next. If self last is still none, we return none. I guess we say let's how do we want to handle the fact, like, what if his t is not copyable, right? Say it's like something that's expensive to copy. Then probably we actually want to return references to these things. Seems maybe reasonable. So maybe we do like, if self current is none, we say self current is equal to self it next as well. And then at the end, we say self last equals self current before we return anything. Cannot move out of self current, which is behind immutable reference. So it's got to be stood mem take. Okay. So that nothing here seems too crazy. And then we'll just maybe the reference, the thing we return is references, like this. Cannot return this without an explicit lifetime. Really? Do I have to write, like, lifetimes like this? Is that legal? Lifetime parameter is not considered by infiltrate. Ugh. Okay, so it's not clean. What do these guys do? Item is T item, where T is a yeah, okay. Gross. Okay, so maybe this isn't trivial. It's not, it seems like it's not super trivial to do generically. So I'm not really sure I'm the biggest fan of this route. Not the biggest fan of that route. So is there... Maybe I'm okay with this, is kind of the answer here. So I think these aren't required anymore. And... maybe these guys look like this. This doesn't have to be peekable anymore. Oh, right. This version didn't work. Fuck me, man. So we're actually kind of back at, like, what, this state? Which, I guess, is kind of fucking ugly. Oh, you could use a while let loop. Oh, yeah, that's not too bad. So you could say, like, while let sum prev x prev y. Like, you do, like, some, like, shitty tuple like this. Then you say, like, it next, like this. Oh, that's not too bad. I'm not super against that. Oh, no, you can't do that either, though, because, this is not like a sliding window. I don't think you meant with the peak version. Oh, so you're saying, like, while let sum x y is equal to it next. And then in here, you could do let next x next y is equal to it peak. Else break. Yeah. And then I don't have to worry about this. And then all of these previous's become nexts. And this has to become a next x, next y, next x, next y. And then probably we want to clone these guys. Yeah, that's not too awful. I'm kind of okay with that. As long as it's correct. Yeah, that looks a lot less shitty. That's really a lot less. I'm a lot happier with that. Okay. Yeah, let's do that. Let's do that. Git add -u, git commit -m, smiley face. And then we check out our rebase again. And now we're kind of in a spot where we can backport that backwards iteration thing without it being too shit. Yeah, I'm okay with that. I'm okay with that. Okay. Lib diff lib. So let's go back to showing the reference version. Git show rebase ref lib diff lib source lib set file type equals Rust, go away. Myers backwards iterator. We need to like look at his implementation. Again, we copy this. Boom, boom. Copy, paste. And no more generics yet. Okay. Okay. This should be Myers trace. Yep. Okay. And then we copy this like backwards walk thing, wherever that was, function diff. Where did we add that code? It was here. So it was, all of this gets replaced with this Myers backwards iterator. Yep, chillin'. And then we also need to pull in that push traversed item change that allowed arbitrary lengths. There we go. All right. Shortest edit distance doesn't exist here anymore. I guess this was algo D. That's how far we got. This is no longer used. These are no longer used. Okay. Sure. Sure. Cargo check. Cargo test. Hopefully we didn't fuck anything up. We did fuck something up. So what is no good here? Length here is getting fucking slapped. Right, so all of our traversals are hitting max length, which is a bug. So why is that happening in our version now, but it wasn't before? What did we do wrong? This looks fine to me. Our length is next x minus x. Hello? What the fuck? What did I fuck up? He's negative. It's because the order here was wrong. Whoops. Whoopsies. Okay, there we go. Tests passing. And now we can cargo format, cargo clippy. Get diff, and let's do -w. Maybe we'll do get dt. Here we go. No white space tracking, and let's just see. I guess this version is actually significantly different. So before we were iterating by x and y, and now we're iterating by d and k. And I think I'm just going to tank that change and say that it makes more sense to do it that way. Yeah, okay. And I guess we should also quickly review this, like, iterator to make sure it makes sense. So he has some current D and K position that are populated by on construction. He's got some limit, which is, like, when he's going to stop iterating. I guess technically that's not required at this point. So we could delete that, because at this point in time, we are only ever iterating to D equals 0. Which, fuck it, we'll leave it in. We'll leave it in. Okay. And so now, instead of, before he was iterating in, like, X, Y space, so reminder for, well, I guess reminder is kind of not true, but for those of you who have not been here or have forgotten, so if in our, like, diff builder algorithm thing, you kind of have this, like, X and Y axes, where Y represents destination string, X represents source string, and then the algorithm works in like this like DK space where K is kind of like this way and D is this way. So the idea is that D represents like steps of the algorithm of like, imagine like a breadth first search. Algo, and then K is kind of like which branch we're on. And that's readable and legible. We can see, anybody who saw me write this will know what it says 3 seconds later. But the idea is that like by iterating in DK space, you can like convert between that and XY, but DK is like kind of like your storage space, which makes some things cleaner. Okay, so due to the greedy nature of the algorithm, we may get a movement that looks like this. Yep, this needs to be mapped to both the traversal and deletion, which needs to be returned 2 line segments. From the perspective of this iterator, this means that we need to return twice for this move. For each DK, we see a diagonal. We cache the second move. If we see a diagonal, we cache the second move. Yeah, it makes sense. So if there was a cache value, we return the cache value. And we consume it. Great. If we hit the limit, we say we're done iterating. And then we do what should be the very similar to what we had in our previous version. So here if we look at B or A only, our source thing, we deleted... Is this the wrong diff? This doesn't feel like what we just did. Get diff tool head. Let's look at A only. Here we go. This is what we deleted. So here we used to say, well, these things, so we got the move source, then we extracted our previous X and Y values. So here we extract our current X and Y values and our previous X and Y values. Nice. And then we get the difference. And while these guys were different, we were traversing, and now we do one long segment. Sure. That makes sense. Makes sense. And then down here, we change this to say, we split out the iterator, and then down here, we use the iterator instead. And then we also have to add a length parameter here. Yep, okay, nothing crazy here. Nothing crazy. So here we'll say, split out backwards iteration, split out Myers backwards iteration into iterator, I guess. And we can provide some motivation here, and so we can say, in future commits, we will want to be able to backtrack in multiple contexts. Split out backwards iteration now to facilitate that change, I guess. While we are here, we have gained, while in the area, we have gained a much better understanding of the data format for the algorithm. In this case, it makes much more sense to iterate in DK space, the storage format, instead of XY space. New iterator uses DK and derives XY as it goes. Sure, good enough. Yeah, sure. Okay. So now I think we have all the pieces that we need to add initial diff visualizer. And I guess here we just need to make sure that I want to double check. I'm pretty sure that our test passed at this point, but wanted to double check. Solid, 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 solid. Okay. So now I guess it probably makes sense to just check out everything from our reference implementation, or our like where we're trying to get to. And we have all of this stuff related to diff viz, and we can just delete the stuff that doesn't make sense. So let's maybe we do like a git reset -p. So we keep this, we keep this, we keep all of this. That makes sense. And we're going to keep the addition of diff viz. Now this stuff, we have to decide if any of these changes make sense. So we don't need this like genericism of Myers trace yet. And so that's kind of what all of this stuff is. Calcful, trace, blah, blah, blah. This is like linear stuff, Myers trace stuff, Myers trace stuff. I guess probably we're just going to unstage everything in... Yeah, okay. Sure. Cool. Okay, so now we have almost everything we need. We can just kind of try to build this now, and it's going to complain that a bunch of stuff doesn't exist. So we can go into our diff viz main, and let's just kind of start him at a point where he makes sense. So at this point, we don't have any like clamping of where in our graph we're searching. We don't have linear implementation. We don't have forgetful implementation. We don't have backwards iteration, which makes all of this much simpler. Max memory bytes, I guess technically we could still use, but there's not really any real need for it at this point. Which makes all of this stuff kind of go away, and he only needs to extract A and B as arguments here. Help still makes sense. Oh, and I guess parse I32 args list. That still needs to be there. Okay. Then down here, top, bottom, left, right, go away. All of this stuff can go away. All of this can go away. It's just A and B. Just A and B. Which kind of means that all of this goes away as well. There's no real errors that can happen here. Unless... Yeah, there's no real failure case here. Yeah, okay. So this just becomes args. Args, matey! And then from our help, we have to delete anything that's not A and B. Which actually was never in here, which is kind of funny. List of I32s to start with. And B is a list of I32s to end with. All right. Cool. So construct diff algo from our arguments. This is basically just going to be a diff algo generated like this. I guess technically he can be unwrapped, and GUI diff algo doesn't have to exist yet either. We'll probably want to add back in the max memory here, but we'll have to come back to it. Fix me, add back max memory argument. Okay. Okay. And so this guy is now just going to be a diff algo. Yep. And so this guy doesn't have like any matching to do. He just has the one case. Yep. And this guy Clippy wants me to collapse this, so we'll allow him to control us, even if I think the code is worse. We only have this full version, so we just kind of rip all of this out like this. Boom, all that code goes away. Okay, and then this is self.algo debug info. Okay, so the debug info stuff doesn't exist yet, so we have to add it. Which I guess is just on our diff algo here. So let's git show our reference. libdiff source lib. Yep. Set file type equals Rust, and we can just look for a function debug info. And it's just this stuff. Now, probably it doesn't make total sense to put everything in here yet, so we'll just kind of see how it goes. Okay. So top, bottom, left, and right, these don't need to exist yet. And so now we only have steps. We don't have any direction or clamping to handle yet, so it's just going to be each X and Y are only going to be mapped as XY. So it's going to be like, I guess maybe that there's no mapping that needs to be done here. The XY space is one-to-one with graph space. So say, let steps for K look something like this. This trace needs to be mute self.trace, boom. And this is going to be vec i32 or something? I don't know. What is the return here? i64, vec i64, i64. And this needs to be mutable. All right, cargo check. Is that everything? No, because in our diff viz main, at this point in time, we do not have to draw any bounding rect ever. So we just get that out of there. And there's none of these like linear things to look at up here. Get out of there. And X spacing and Y spacing do not need functions associated with them yet. Unused. Okay. So now, we should actually have a visualizer that kind of works. Maybe? Which it does look like he is. He's got very few options, but this is kind of like the rudimentary version. Nice. Okay. So that's working. So you can git add-u, cargo format, cargo clippy, and everyone's happy. And there are some things that I saw in there that I wasn't quite happy with. Let's look at them again. Let's just see if I can spot them. I wasn't happy with this like point abstraction and like this guy being a bunch of lines that are just tuples of i64s. This doesn't feel very good. But I think I'll come back for this. Because I think that like it'll be easier. I think I'll probably want to do like I'm in like split mode right now, so I kind of want to keep splitting. And then maybe I'll come back for that. Maybe I'll just slap a fix me on it so that I don't forget. Or should I just do it? Maybe I just do it. No. Maybe I actually am okay with this. Yeah, okay. You know what? I'll be okay with it. It is debug info, so the debug info being kind of like weird in terms of data format doesn't seem crazy to me. Okay, sure. We can say that that's a reasonable commit. So we can say this is add diff visualizer. As we start to adjust the diffing algorithm, having a way to visualize will be key will be a key component of debugging. Add a way to extract debug information from current algorithm state and show on a grid in the new diff viz app. Sure. All right, that's probably good enough. Like, if I were to like look at that commit, would I be like, that's a sane commit? Let's see. So I would see some cargo lock changes. It'd say, hey, we have new dependencies. Add diff visualizer. As we start to adjust the diffing algorithm, having a way to visualize would be a key component of debugging. Add a way to extract information from the current algorithm state and show it a grid. Okay. And we would look at this guy, and we'd look at the changes here, and we'd say, hey, new debug info thing. And he does like the same iteration that we normally do, and we like backwards iterate over each k value, each diagonal, and we push it in. Yeah, that doesn't feel too bad. It doesn't feel too bad at all. And then I would look at this and be like, oh my god, GUI code. But in reality, none of the functions in here are like too crazy. They're all pretty like small and contained. Like draw element position, takes in a galley and a painter, construct diff algo. Yeah, sure. Add margin direct. Is this used? Oh, it is. Draw headers. So here we lay out the elements and we put them at grid positions, draw grid lines. So here draw diagonals, nothing crazy. Draw dots, draw active dot, draw active paths. Yeah, nothing in here is crazy. Render algo state. Yeah, I think that's fine. I am fine with that. Okay, so now I think we're at the point now where we have like an initial thing, and now we have to start adding in the features that we were actually adding in. So probably adding backwards iteration, forgetful iteration, and clamped iteration all separately, and in the visualization will make sense. So I think those are probably so. Let's look at. So we'll say backwards iteration, clamped iteration, and forgetful. Okay. Yeah. Forgetful iteration, and then we should be able to say linear. Okay. Hell yeah. So I wonder if at this point it might make more sense to start doing like patch in changes. Maybe. Let's look at how far off are we from like the rebase reference version of these things? Forgetful trace. Oh, I want it the other way. I want it to be the difference between me and rebase ref, not rebase ref and me. So yeah. Boom. Yeah, it does kind of look like probably at this point doing a git add -p is probably the way to move forward for a lot of it. Let's try that. So we'll check out rebase ref. So now all of our changes are staged. Git checkout here. So we unstage. Hello. Checkout. Oh, it's git restore stage though. Yeah, there we go. So now all of our changes are unstaged. We can say, hey, I would like to slowly add in some of the changes we made here. And it looks like the first chunk we're going to be doing is we're going to be adding the forgetful version of the trace. So that's, we changed this like trace thing to be a trait with 2 implementations. I think this stuff probably isn't needed yet. Calc full trace. I might unsplit that function because it doesn't really make sense to do it here, but I'll add it for now. This stuff here is a lot of like linear algorithm. Holy fuck, what is going on here? This is a big chunk. I think we don't take this. No. We don't take that. And we don't take... Well, we have to take some of this, so I guess... what a pain. What a pain. I'll just say no here. This I will take, because this is now going to take in, like, the forgetful or unforgetful version of the trace. Don't take that. I think. Yeah, don't take this. Don't take this. This we take. Okay. And then we make sure that the only things that we took are Myers trace related. Full Myers trace, full Myers trace. We didn't get the forgetful Myers trace changes in here, eh? Probably because they were bundled with a bunch of other shit. So we have to go back to saying git checkout every current state, fuck everyone else. And then we can go git show rebase reference, libdiff source lib, set file type equals rust. Brownhound's raided with the party 2 viewers. Thanks for the raid. Appreciate it. Appreciate it. Okay. So here we just need to copy in the forgetful version of the trace as well, which doesn't look like actually that much code. So probably here we just kind of paste this here. And then when we construct this guy, we need to fix the fact that he now has this like multi-version trace. You know, we couldn't really pull that in because it was pulling in too much of the other linear algo stuff. But so now our trace is an algo trace, which means that we kind of need this like algo trace thing, which I guess comes before the debug info is where we put it. Boom. And then I guess we want to copy. Let's see, what are we doing here? So now we have like multiple types of constructions that we might want to do. We might want to do full or forgetful, I guess. Yeah. Okay. So here we'll just say, I think we'll start splitting out this new with trace function that we had in the latest version, except we don't have directions. We don't have top, bottom, left, right. We just have the trace, which means that all of this stuff kind of goes away. But the max distance calculation stays, trace stays, boom. And then new now delegates to new with trace. Say new with trace. Yup. And we pass in a b trace. Okay. Okay. And now we need to do the forgetful version, which doesn't have a max memory, doesn't fail. And this now constructs a forgetful Myers trace, and this guy should actually construct a full Myers trace, which we actually didn't get the rename of, I don't think. Okay. How fucked are we compilation-wise? It's not great. It's not great. So this has to say T here, and then this guy has to say T here. Remove this generic argument. Oh, because this guy needs a T here as well. And I guess this guy needs a T in here. Struct defined with one generic parameter, so this guy needs the T as well. And now are we mostly chilling? Almost. New with trace. We forgot to say algo trace full here, and algo trace forgetful. Yep. This guy doesn't have to be wrapped in an OK anymore. And we compile. Okay. So now the piece that we're missing is probably that we need to be able to use the forgetful version of the trace when we use our visualizer. So here we want to add back in the like forgetful argument. So probably we say git show rebase ref source diff is source main. Yeah, nice. And here we need to pull in like, so we have this like forgetful argument, and we need to parse that forgetful argument, which means that up here we need to say, hey, we have this like forgetful thing, and if you pass it in, then we have it, boom, boom. And when there's no like argument parsing to be done with that, no like error cases, it's just if they pass it, we have it. Which means that this guy now needs to say that he has the forgetful argument, this. And then we have to use that when we construct him, so construct diff algo. And so I guess here we just say if, well, let's see what we did here. Yeah, we just say if args forgetful, else we do this. And the difference here is this is just new forgetful. Boom. And then I think that the other thing that we're missing is we needed to visualize the forgetful stuff. So probably if we run this right now, probably it's going to do some dumbass shit. That's what I suspect. Yeah, it's doing some dumb shit for sure. Right, you can see it, but it's close. The only thing that we have to do is when we backwards iterate, we need to set a limit. So here we need to do something like match self trace, and it's something like algo trace full. We do maybe we say like let d limit is equal to this, and if it's this, we say the d limit is 0. But if it's forgetful, it's going to be self.d minus 1, I think. We're gonna have to double check this against the original. So git show rebase ref lib diff source lib, and we can just look at debug info. So what does he set the d limit to? Self.d minus 1. Yeah. Okay, so now if we run this with forgetful mode, we should see that instead of seeing like a full path, we only see like the last thing that happened. We crashed instead. Perfect. So this is at an assertion at line 300. Interesting. Interesting indeed. I think we've hit this bug before. I've seen this one before, where the whole reason we added this assertion was because we wanted to make sure that the D and K values line up. But I don't remember why that happened. Set file type equals Rust. Okay, so this they did like a forwards, backwards, local to global. I don't really see any reason why this should be different. D limit self D minus 1. Self D minus 1, XY trace. I guess in this version, we didn't actually do that assertion when we were doing the forgetful debug info, which might be relevant in some way. Can we just like actually look? Let's Rust GDB target debug diff is, and we'll just pass in the same arguments. We might actually just be hitting a new bug that's just like manifesting in a way that it didn't before. Okay, so we hit next year. Why the fuck are we panicking? Holy 70 fucking frame backtrace? What the fuck? Okay, so we're probably at like what, like frame like 7 or something? Frame 8, frame 9. So what's going on here? We are trying to look at D minus 1, K minus 1, and we have PD, PK. D is -1. That's the bug. D should never be -1. So what's happening there? Oh, there's a bug. I see. So here, when we... Did we limit D somewhere here? Yeah. So why... D getting to -1 is a bug here. Is this in get move source? Okay. So why does this not happen in the current version? Maybe it does. So in get move source, it's supposed to be if D is equal to 0, but somehow D is getting to be less than 0. Ah, maybe. Let's run that again. I actually need to double check that. So break Rust, panic, run, hit next, we crash, we backtrace. And we need to look at maybe frame 13, frame 14, frame 15, frame 16. I could have sworn it was 13. Get move source. Frame 9, frame 10, maybe. Okay. So here we have D limit -1, D -1. And we are here. If self.d is less than self.d limit, which it's not, this feels like just an obvious problem, but I feel like I'm missing something. I'm missing it. Let's just print line D and K. Alright, yeah. On each iteration here and just see if we're doing something like fucking stupid. So I really feel like it shouldn't be that dumb. So we start at D 0, K 0, then we get to D -1, K 0. Okay. So we start at D 0, we subtract D 1. and we say, hey, if d equals 0. I mean, is it just that my d limit shouldn't be -1? It should be 0? That seems reasonable. I just don't understand why this wasn't happening before. But that's okay. Let's try that. Let's try that. I mean, that looks right. This is what we expected to see, where he's kind of iterating, and we're only ever showing, like, the last move. Yeah, okay, sure. Fuck it. Fuck it. I don't understand why that isn't needed in, like, the latest version of the code, but that's fine. It's fine. And this whole time we weren't working on backwards iteration. We were working on forgetful iteration. Okay. Cargo format, cargo clippy, cargo test, right? Just make sure everyone's happy. Cool. And what did we actually do here? We added a forgetful argument. If it was forgetful, we construct the forgetful version of the thing. We convert the Myers trace from... We convert the Myers trace from a concrete type to a generic interface. And we implement 2 versions of those generic interface. Yep. Okay, nothing crazy. Nothing crazy. Okay. What? I'm confused. Why do we only want to show only the last action, not the whole path? Right. Okay. So I will explain that as I commit this. So we'll say implement forgetful iteration. And we will say in the linear version of the algorithm, we need to do 2 passes of... We need to do 2 iterations of the graph. One where we run the graph, we run the algorithm forwards and backwards at the same time without remembering where we came from. When the forwards and backwards passes collide, we can bisect the problem and do the full memory version on a smaller area of the graph. Saving memory. Yeah. Implement a forgetful version of the algorithm as a first step, as a step towards the linear version. So we can kind of show the way that works in the latest and greatest. So if I go back to rebase ref, oops, git add -u, git commit -amend. So if we go to the final version of this, we can show the linear version in action. Hold on, we have to set a limit. So max memory bytes, we can set this like 1,000 or something. Yeah. So here you can show, like, we're showing one step of the algorithm at each point, going forwards and backwards. And here they're going to run into each other, and they're going to say, hey, now we have 2 smaller versions of this algorithm, and we can run those. And then it does the same thing for each of these smaller boxes, and then it does the forwards walk. And that's like the whole thing that we've been working on for like the past few streams, is trying to get to the point where we can do this. So that's why it like, you're right. In isolation, it doesn't make sense to only ever show the last action, not the whole path. But it's helpful in bisecting the problem. What are we making? Yeah, I guess we don't have that written anywhere. We're working on a Git GUI, and as part of our Git GUI, we're working on a diff. We're working on a diff tool. And as part of that diff tool, we are fixing our diff algorithm, and as part of the diff algorithm, we have implemented a visualizer to help us debug that thing. So, and as of today, we're saying we've done a week of work it's like spread out and shitty. So we're trying to do some like code cleanup to kind of get to the point where we have like a nice reviewable thing that we can work with. Can you create a function pointer in Rust to a function that takes arguments? Well, the argument itself. I mean, there's like a function trait in Rust, right? You have the like, you can do something like, where do I want to write this? Maybe already here. You can do something like function, my function that takes in some generic f, who is a function that takes in like two i32s or something. And then you can say like f is an f. And then in here you can call f with 1 and 2. I'm pretty sure that's valid Rust. I'm trying to get an f in type. Oh, I think that's possible as well, but you can't. You can do lowercase function types too, but they're less flexible. So I think you can do something like this. Is this allowed? And then you can call like function call is going to be like my function with function to call is going to take in two i32s. And then here you can say my function with function to call, I think. I think that's all valid. Like, I don't see any reason why any of this doesn't work, but I'm not really sure what you're trying to, like, hit. But I think that it's possible to some extent. It just depends on... Maybe you're hitting some edge case, not sure. Okay, forgetful iteration. Done. Next up, clamped iteration. So, clamped iteration was, as we split up our problem into smaller subproblems, we want to be able to start and end at those subproblems. So, maybe we do something like, we'll probably do git checkout rebase ref. So we pull in all of the changes from that are between us and them. Git restore staged and git add -p on libdiff source lib. Okay. So what a useless -p. Can I like say that to like limit how much it's gonna add? Git add -p help. Like, can I reduce the size of these guys? I guess we could do git add -e, and that's kind of like the same thing, but on libdiff source lib. Okay, so limits, this is what we're adding. This stuff we don't need. No algo walk direction, no linear debug stuff, no snaking, so all of this stuff goes away. Boop boop. Linear diff stuff all goes away. Fuck all of this. And the walk direction goes away, but the limits stay. Limits stay. Limits stay. And then this stuff is all the same. Remove the forwards section. Remove backwards. I guess this whole new backwards thing doesn't even exist. At all. This new with trace stuff comes in. Get diff-u can limit the context lines of diff. Yeah, but I don't know if that works with like patches. But I guess we'll find out. This is related because we need to limit like where in the diff we're pulling from, but this stuff is not. I feel like this stuff mostly should stay as it was. Mostly. So we're going to kind of do something like this. I'm not quite sure this is right, except this while is going to change to this extract from source. No, it's not. This is all the same as it was before. This is all the same, and this is all the same. Surely at this point, I've fucked up the diff to the point where it's not going to apply, and that's going to really piss me off. Surely. But... yeah, it would have been nicer to do this more patchwise. This is too much. Too much. Okay. Git add -p. So libdiff source lib. Okay. Ugh, it's just the same fucking shit, man. It's just the same shit. I shouldn't have discarded my work. I shouldn't have done it. But you live and you learn. This is why I'm glad that my work code isn't public. I just add smiley faces. Yeah, I mean, I do that sometimes, but I find even for myself, it's just too hard sometimes. You go back and you're like, what the fuck was I doing? You just have no fucking clue. Here's what I'll do. I'm going to take all of these changes for now, and then I'll just delete them later. Yeah, I think that'll be easier. Then here, we delete this. And I'm going to take these as well and deal with them later. Okay. So that actually was okay. So now this stuff, do I want any of this? I want some of it, so we delete this, we keep this, and now this stuff is going to change like that. Lets you pick yes or no stage of each other. Yeah, I mean, it's just the problem is that the patch is like way too large, so we're kind of in that fucking bullshit state anyways. I think I'm just not going to take this. Well, let's see how much of this is. Yeah. I'm just not going to take this one. That'll be easier. And I'm not going to take this. I'm not going to take that. Not going to take that. Not going to take that. Okay. It's not perfect, but it's a start. So... at the very least, we're going to have some compilation issues with what we pulled in just now, so we're going to go and fix them up a little bit. And let's just start hitting them. Okay. So, direction is a no-go. Direction is a no-go. This doesn't exist yet. We haven't implemented backwards iteration yet, so. Argument of type I64 is missing, so what doesn't it like? Oh, it's this is not supposed to be there. Okay. So here. Oh, interesting. We took this? I don't remember taking these changes. I probably didn't want to. But I did want this right minus left, bottom minus top thing. So we're gonna have to, we'll come back for this in a sec. Maybe we won't. Git show current head libdiff source lib, and we can compare what the fuck did we just do here. So we can look at functions. What is happening? Function step. And it's just the break condition. Oh, we do want this. Nice, we do want this because once we've added this like clamped iteration, we need to handle this case where we need to make sure we're not iterating outside the box. And that's what this was for, was that we said as we iterate through, like as we step, sometimes we're going to step through places that are not relevant and we just have to skip them. So this is actually what we want. We just need this to be self.right, self.left, self.bottom, and self.top right now at this point in time. And then this is going to be algo action none here. This extract from source thing I think is not what we want. So we're just going to say, we're going to go back to this version of the while loop. And that seems okay. This guy needs to add in the area here. So this is just going to be top, self-top, left, self-left, right, self-right, bottom, self-bottom. chillin'. Here, we need to specify the top, left, bottom, right. So top, left, bottom is B len, and right is A len, I think, which is an absolutely disgusting API. So maybe we should fix this. Awful API, but we'll come back for that. And is there anyone else in this file? Nope. So it's just now these guys need to populate these arguments. So git add-p or git status, git diff, git add-u, git commit-m, and smiley face for now. We'll adjust this in the future. And now we're going to check out rebase ref, and we're only going to take the diff visualizer main, and we're going to restore stage and try to do a slow add here. So here we don't want these changes, and here we only want the ones related to top, bottom, left, and right. So fuck this, fuck this, fuck this. Same here, top, bottom, left, right is all we want. Oops. This would be a space here. There we go, nice. These guys, we only want top, bottom, left, right. And here, we only want... Oh, geez. What changed here? So here, we put this stuff, top, bottom, left, right need to be parsed into integers. This goes away. Backwards and forgetful, we don't have this constraint yet. Linear, backwards, and forgetful, we don't have that constraint yet. Top, bottom, right, left, right. We don't have backwards or linear or max memory bytes. Nice, nice, nice. Okay, something like this. Okay. Chillin'. When we construct the diff algorithm, we do need to extract top, bottom, left, and right, but the other stuff stays as it was. So this has to look something like this goes here. And this looks like this. I think that applies. I hope. Nice, that applies. It's not perfect, but it's good enough. We draw the bounding rect. Nice. I need to add in this X spacing, Y spacing. Don't take that. Don't take that. Don't take that. Okay. Git, checkout, current, discard anything else. And now we're close, but not quite there. I think that we fucked up some amount of stuff, so. We just have to fix what we fucked up the rebase with. So this goes in like this. This has a new line. Unclosed delimiter at 148. Wow, what's going on here? Ah, I see. It's like this. And I think this goes at the bottom of the list here. And then these guys need, this one needs top, left, bottom, and right as well. Okay. So I should be able to say, hey, I would like to limit where the algorithm is going to run. So I should be able to say top, 3, right, 4. And that should give me top 3, right 4. Nice. If I say top 3, left 4. Yep. And then if I start iterating here, that's a bug. And it's doing gyros. It's iterating the right spot, but it's not rendering in the right spot. So it's when we draw our algo state, probably... where was this handled in like the current version? Probably in the latest and greatest. This happens in lib diff lib. When we extract the debug info, they probably add in top and left here. So let's take a look. Let's take a look. Rebase ref. I like how I say they like it's not me. I do the same thing over here. So rebase ref libdiff source lib, and we can look for steps for k. And yeah, so we have this like local to global xy thing function, and we use this to adjust x and y by left and top. Right, so on here we just have to say map x y to x plus self left, y plus self top, which is very slightly different from the way it looks in the end, but it's fine for now, probably. It's probably fine for now. Much better. And does that look correct? Yeah, that looks right. Looks right. Correct enough, at least. And let's do just bottom 6, 5, 6, right 6 as well, just to make sure that like end iteration is handled correctly. Yeah, looks good. Looks good. Okay. So we can say, let's just check all of our lints. Nice. And let's just look at the diff as its own thing in isolation now. So we add in to our argument parsing the ability to look at top, left, bottom, right. I guess get dt is probably the better way to do this. Top, bottom, left, right, and now our parsing can fail because the things that we pass for top, left, bottom, right might not be valid use sizes, so we say, hey, fuck off. We add those to the help. Forgetful is not in the help. We need to come back for that. But this is fine, so we say, hey, let's add this stuff in. Where is this stuff getting moved from? 375? Oh, that's so funny. It correlated these top, left, bottom, right things from like two completely unrelated spots. That's pretty funny. We draw the bounding rect now in blue. Yep. And that required some X spacing and Y spacing. Things to be exposed. Yeah, all right. Nothing crazy. Nothing crazy. So you can say add support for limiting search graph search region, diff search region. And I guess really we should probably copy paste this. Oops. I guess we actually are squashing this into the smiley face commit here. And here we paste this. Add support for running our diff algo from on a subset of the whole graph. This, sure, fuck it. And then I just want to make sure that I don't remember what was in that smiley face commit, so we just have to double check if there's nothing stupid in there. This is top left bottom right, top left bottom right, top left bottom right assertions that are like ranges are reasonable. Yeah, nothing crazy in here. Oh, here I guess we probably should call this out. This is a change that's not like obvious what it's doing. In note, we'll say this is in the step function. In algo step, we now need to ensure that each step of the algorithm only works within valid ranges of within the valid range. How do I want to say this? We have to add a loop to skip any outside of range elements. However, we still need to populate data for these elements, as the algorithm will try to use it. Yeah, there we go. Okay, cool. And then the rest of this is just box relative stuff. Okay, cool. Cool. We're close. Now we can just add in the backwards stuff. I'm gonna go over the 2-hour mark just because I feel like we are close, and I wanna finish this up. So we can add in the backwards stuff. So git checkout rebase ref this, git restore stage this, git add -p. So none of this. We do want backwards. We want backwards. We want backwards. And now we have to say, we actually do have this like backwards and forgetful condition. So it looks like I don't know. We have this constraint for some reason. I don't know what it is, but I'm going to trust previous me to have been right there. And there's actually no backwards in here, but we'll just add it. Backwards. Run algorithm backwards. Sure. And then here, now we have to... I'm just not going to take this diff. We'll do it by hand. We don't need this. Don't need this. Don't need this. I'll go walk direction. Okay, some of this seems relevant, so... This should say none here. I'll go walk direction forwards, backwards. We don't need this linear stuff. This none is supposed to be here, which means that we don't need these pluses. Oh, what a pain. What a pain. Okay. Delete anything related to linear algo state, linear. Okay. Sure, but we do take this new diff algo walk direction thing. So here we go forwards. Now we add this backwards version. So I think that's fine. Direction. If we are going backwards, we have to invert X and Y. Gotta go. Thanks for the stream. We'll catch you tomorrow. Bye. Yeah, thanks for watching. Catch you on the next one. So this is like when we're iterating backwards, we need to make there's a reason for this where we need to invert our axes as well and invert which the source and the destination is. We kind of do this like, there's a reason. There is a reason. Which means that we need all this. We don't need that. And this stuff is backwards and forwards iteration related as well, so we'll take this. I don't want any of this. But I do want that extract from source function. Do I want that? No. Don't want that? No. Don't want that? No. Don't want that? No. Okay. I think that's almost there. The only thing that we need to fix is the construction stuff. So that was in, where is my editor? I guess I closed it. I was in diff viz main. We had to construct our algorithm. And here, now we need to say if args backwards. We need to make a new backwards. Who takes in top, bottom, left, right. Sure. Yeah, seems reasonable. So now if I cargo run with the same thing but backwards, fuck. We accidentally took a D incremented here when we didn't want to. Okay, so now he is going backwards, which is good. Yep. And if we run it backwards on like the whole thing, we go boom, 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 boom. I think that's fine. That looks a lot like he's doing the right thing. Okay. However, let's very temporarily just show the full path backwards, just so that I can like visually confirm. And arguably, this should be something that we can do as part of our API, but fuck off, I guess. Yeah, that looks good. That looks fine. Cool. Cool. Okay. Cargo check. Cargo test. Cargo Clippy. Clippy's mad about this function with too many arguments. He can go fuck himself. I don't really care. Allow Clippy too many arguments. I don't care. I don't care. Cargo format. And we can say add backwards iteration. So this is going to be the same thing where we're going to want this same little blurb at the beginning about linear version. And here we'll just say add support for running the algorithm backwards. And am I happy with that commit? Add backwards iteration, blah, blah, in the linear version of the algorithm. We need to do 2 iterations of the graph. One where we run the algorithm forwards and backwards at the same time without remembering where it came from. When the forwards, blah, we pass the problem to the full memory version on a smaller path to graph same memory. Yep, okay. So backwards. If backwards and forgetful, that's an invalid combo now. We added backwards. Now we have algorithm walk direction. And the only change that we really do here is if a backwards walk is the same as a forwards walk, flipped over x equals y. If we just invert everything, all of the code works for free. Take some selfs out of here. Great. And then this like local to global xy stuff changed. That's fine. Yeah, okay. Nothing too crazy in there. That's a very consumable diff, which is good. And I think probably now, if we get DT to rebase ref, I think probably everything that's left is like related to the linear version of the diff. So this is linear related, because with linear, we have to specify the maximum memory so that the linear version of the algorithm knows when to stop iterating. Here, we're like, hey, we might be a linear, we might be a full. So that's what this stuff is for. Handling of linear and full. Here, the linear version of the algorithm like uses the existing version of the algorithm, and so he kind of needs to know a little bit more about like what the inner version did. Snaking state, some rect stuff, like kind of like binding which area of the diff we're looking at. This stuff is going to need some like massive cleanup, but I think I'm not going to do that at this exact moment. Yeah. Okay. So it looks like this is like some code that doesn't need to be added, but it looks like almost all of the rest is related to the linear algorithm implementation. So I think we're good. We're kind of on the last commit. I'm going to call this one whip rebase ref here. I'm going to say maybe there's a few changes that are like just typos and stuff that we don't want. So I'm just gonna do git add dash p anyways. Yes, 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 yes. No, yeah, we need that. We need that. We need that. We don't need that. We don't need that. We don't need that. We do need that. We do need this. And here we will take the new version of the diff function that is linear. We will destroy the old version of diff. I guess we might just leave this debug in there. I'm not sure why that's there. We don't need that. We don't need that. Yeah, we do need that though. Okay. So let's just do linear max memory bytes 1000 just to see. This should do it. This should do it. I fucked up. No backwards or forgetful with linear. Sure. So here we go. Smack, smack, smack. Yeah, looks like it's working. Okay. So I'm gonna call this one git commit, git status, git commit, whip linear algo implementation. Because that's enough for today, I think. Because I think that the actual cleanup on the linear version is, there's like actually like a lot more code cleanup that has to be done here. Like this is just like a fucking disaster. Like look at this function. This is like what, 450 lines long. So I don't know, like this isn't gonna be quick, but I think that we're kind of at least in a state now where everything up until that last commit is looking like pretty good. Like if I read through these step by step, you know, this is like a deduplication, which feels good. Split diff into state machine, also pretty consumable. Split out Myers backwards iteration iterator, also very consumable. Diff visualizer, consumable. Forgetful iteration, limiting diff search region, backwards iteration. Yeah, feeling pretty good. Feeling pretty good. So I think I'm gonna call it there. Thanks for watching, guys. I don't know how I feel. I'm gonna have to watch this VOD back and decide if this is like actually interesting content or if this is like a total waste of time. But hopefully, even if it was a total waste of time, hopefully you liked what you saw anyways. And if you did like what you see, I stream most days at around 2 o'clock Pacific time for a couple hours. So if you're online in the hours of 2 to 4 and you want to come see what we're working on, feel free to swing by. Right now we're working on this like Git GUI, but we cover like whatever the fuck I feel like working on, and thankfully, lucky for viewers is my focus bounces around a lot, so we get a lot of variety. So we've done like operating systems, neural networks, web dev, like Git GUI, diff stuff, like 3D OpenGL stuff. It's kind of just like virtual file systems, like just whatever I find interesting at the time is kind of the theme. Code is on GitHub under the same username. There's a link for that in the Twitch description. And YouTube VODs are on YouTube under the same username. Link for that is in the Twitch description. And if you're on YouTube, there should be a link to the Twitch stream in the YouTube description. If you made it this far in the YouTube video, you almost certainly will want to swing by and say hi. I think that's it. We should be back on tomorrow, I think, but I have to think about what I want to do tomorrow. I think there's it depends on how much I get done tonight off stream, what we will work on tomorrow. Yeah, thanks for watching, guys, and I'll catch you on the next one. Bye!